Welcome everyone. Today we are diving into an exciting new feature of our index, synthetic data generation. In this video, we will explore how this powerful new feature enhances index, allowing users to create realistic and diverse datasets effortlessly. Join us as we unlock the potential of synthetic data and elevate your projects with index. Let's explore the possibilities together. So, what exactly is synthetic data generation? Imagine being able to create tailored datasets that perfectly fit your research needs, all without the constraints of real-world data. This feature allows you to generate artificial datasets using user-defined prompts and existing information, empowering you to conduct experiments and analysis with ease. It's all about creativity and flexibility. Now let's talk about why this feature is a game changer. First, it offers incredible flexibility. You can customize datasets based on your specific requirements, ensuring relevance and accuracy. Second, it saves you time by automating the data creation process, no more manual entry or searching for datasets. And finally, with synthetic data, you're prioritizing privacy, minimizing the risk associated with using real data. It's a win-win. Curious about how this works? The magic lies in three core components. First, we have data generation from prompts. Just provide a simple text instruction and voila. Next, you can enhance existing datasets by generating new rows or columns based on your current data. And lastly, we incorporate few-shot learning. This means you can guide the generation process using examples, making the data even more relevant to your needs. It's all about utilizing AI to empower your projects. Now that we have covered the essentials of synthetic data generation in Index, it's time to see it in action. Alright, to kick things off, we need to load our API keys to access Index API. I've already installed the necessary packages for this demo, so let's jump right in and load our key from the .env file. We've got our API key loaded and now we're ready to create some data. We're going to generate a dataset with 3 columns and 3 rows about astronomy. Let's run this code. We've just created our very own dataset about astronomy. Now let's save this dataset in an Excel file so we can keep it for later. I'm going to save it as output data. Saved. Who doesn't love a neat Excel file? Next, let's spice things up. We'll generate a unique row based on our existing dataset. I'll load the dataset we just saved and run the generation process again. Look at that. We just added a new row to our dataset. This is getting exciting. Now let's take it up a notch with a cool trick called the few-shot learning. We'll give our model some examples to learn from. Let's run this code. We just used the few-shot learning to create a brand new astronomy dataset. And finally, let's generate data based on some fun attributes. We'll create sentences that are either serious or funny. Let's see how it works. And there you have it. We just generated sentences with different attributes. How cool is that? And that's a wrap for our demo on basic synthetic data generation index. We've created, enhanced, and customized datasets in just a few simple steps. Alright everyone, now that we've explored the basics of our synthetic data generation, where we could easily create datasets with simple prompts, let's dive into some of the exciting extra features of our index that truly elevate our capabilities. In our previous demo, we saw how we could generate datasets on various topics like astronomy with a straightforward command which gave us a clean and relevant dataset which was great for quick insights. But now we're ready to enhance our data generation process significantly. We're now introducing an LLM judge into our generation process. This powerful addition allows us to validate the generated data, ensuring that it meets our quality standards. Instead of just generating random outputs, we can actively assess the realism and diversity of our datasets. Let's take a look at how we set this up in our code. First, we load our libraries and environment variables just like before. Next, we define our columns and example data, which will serve as a guide for our data generation. We'll also set up additional examples for our data. Next, we initialize our API clients to connect with the Index and NVIDIA models. Now we'll set up our basic synthetic data generator, incorporating the LLM judge to assess the quality of our outputs. Here's how it looks. I'm also generating some data using the generator with the LLM judge for medical billing examples. This should create complex datasets. Now we'll wait for the generation process to complete. It's worth mentioning that the effectiveness of both the generator model and the LLM judge will have a significant impact on the results too. But wait, there's more. We also want the ability to refine our results further. That's why we're introducing human feedback. In our advanced generator, this feature allows us to review the generated data and make adjustments based on the specific criteria for enhancing our datasets even more. Let's set up our feedback generator. Now we can generate refined data and have the opportunity to review it. If we find any entries that don't quite fit, we can easily provide feedback for improvement. And that's wrap. With these advanced features, we've evolved from a basic synthetic data generator to a robust system that ensures quality through an LLM judge and allows for user feedback to refine our results. This makes our datasets not just reliable, but also perfectly tailored for a wide range of applications. Now let's explore where to use synthetic data generation. Research projects. This approach simplifies algorithm testing. By generating datasets that fit specific criteria, researchers can efficiently validate their algorithms without the overhead of collecting real-world data. Second, for model training. Synthetic data plays a crucial role in improving the robustness of machine learning models. By exposing models to diverse datasets, we can ensure they learn effectively and perform well in various scenarios. And third, for prototyping solutions. For rapid development, synthetic data allows teams to quickly create the datasets they need, accelerating the development process and reducing the time required to prototype new solutions. In summary, synthetic data generation has versatile applications in real world across different domains, providing valuable support for research, model training, and solution prototyping. Now let's recap the benefits of synthetic data generation. It can empower your research. This feature enhances your ability to create customized datasets quickly and efficiently, streamlining your research efforts. Second, by integration of LLM judgment and human feedback, you can ensure that the generated data meets highest standards of quality, reliability, and relevance. Third, versatile applications. Synthetic data generation is not limited to research. It can be applied across various fields, including training machine learning models, prototyping solutions, and much more. In conclusion, synthetic data generation is a powerful tool that enhances both efficiency and effectiveness of data-driven projects. Finally, we encourage you to try it yourself. Explore the capabilities of synthetic data generation in your own projects and see how it can benefit your work. We'd love to hear your experiences, so please share your insights and feedback with us. Your input is invaluable as we continue to enhance and expand our features. Thank you for joining us today, and we look forward to seeing what you create with synthetic data generation.